he's been around. When I was on your side of the table, when I was a customer, he was trolling the Usenet groups, sending code snippets and help to people like me that were struggling through the early days of Oracle. And now he's got the Ask Tom website. So if you haven't gone to the website, go to asktom.oracle.com. If you haven't read his books, get his books. They're phenomenal. But join me in welcoming Tom Kyte.
Negative connotation to it. Good morning and welcome. My name is Tom Kyte. I've been with Oracle coming up on actually 16 years now. I joined when version 6 and version 7 were production, and in the intervening 16 years, there's been 14 production releases of the database, which for me is great because I have a very short attention span, so the constant change is a good thing. Change in general is good. For example, when I got in a taxi this morning by the hotel, by the airport, the taxi driver asked me where I'm going, and I said 23 Cambridge Street, Burlington, Massachusetts. And he goes, Burlington? I said, P-E-R. And I'm like, oh, this is really bad. Until he pulled out the TomTom GPS and punched in the address, and it told us where to go, and we arrived here safely. 30 years ago, GPS didn't even really exist. 30 years ago, the database didn't exist. It was 1979 when the first release, version 2, came out. It was version 2 because Larry Ellison knows that nobody ever buys version 1 of anything. So some 30 years of change inside the database. And what I'm here to talk about today is 11G and what it means to you. About 10 years ago, Oracle EI came out, and they started lettering the versions of the database. And the I in EI stood for Internet. And it sort of jazzed up the name of the database, if you will. Version 7.3 was pretty boring. 8.0 was pretty boring. But then you had EI release 1 and 2 and 3. And then 9i came out. And they were actually thinking of not calling it 9i, but 9e. Because when 9i came out, e-business was the big buzzword. But I'm glad they kept it with the I. It's a little bit more technical. It's core technology. So we had 9i, release 1 and release 2. And then version 10 came out. And until 3 days before version 10 came out, it was called 10i. And I remember sitting next to my now manager as he got the email on his little BlackBerry from Larry Ellison saying, we've decided to go with G for grid. And you just see him do the big face palm because he's got to change all the documentation and all of the cloud, everything in the next 3 days. But they picked G for grid. I looked at 10 and said they could have picked M as well. They could have called it 10M, where the M was for manageability, because that's when they added a lot of features inside the database, a long-term memory with the automatic workload repository and whatnot. But manageability is really long, it's hard to say, grid, short, easy, to the point. So they went with 10G. When 11 came out, I really thought they could have changed the letter again from G to C, where the C would stand for change. Not that it's changing, but rather that it's got a lot of stuff inside of it to make change a little bit more safe. When we change something, anything in software, a version, do an upgrade, a patch, an operating system, add an index, do anything inside of the database, one of 3 things will happen. It's either going to be the beginning of a really good day for you, because it works out really well. It doesn't do anything. It doesn't change anything at all, so it's pretty safe. Or it's the beginning of the worst week ever, because you're going to be backpedaling, trying to introduce change. Any of you who work with version 6 and version 7, any of the version 7s, knows that the first step in making any sort of database change is typically shut down media. Because changes were done in an offline fashion to do a reorganization, to change an init.aura parameter, to change a system setting, typically involved a restart of the database. And back then, that was okay, because prior to 1995, when version 7.3 was production, people actually went home at the end of the day at 5 o'clock. And you had maintenance windows where you could shut things down. Now, when I go to re-sign up for my driver's license, the DMV had better be up 365.25 days per year, because I want to do it at midnight on a Friday night when I come back home. Right? So our databases are up and running continuously. So starting at version 7.3 on up through 8, 9, and 10, we give you the ability to change lots of things, like most of the init.aura parameters, the important ones, the relevant ones, we can now change. I can change memory settings. I can change the size of the shared pool. So we have the ability to do all these online major memory changes. But bear in mind, if it's 3 o'clock on a Wednesday, I change the size of the shared pool, one of three things will happen, right? It might be a disaster. It might lock up the system. I don't know. I haven't tried it out. I haven't tested it. I don't know what's going to happen until I actually do it. Online schema evolution. I'm going to take my biggest table. The table is huge. And I'm going to partition it. Why? Because I read out on the internet someplace that partitioning big things makes them faster somehow. So I'm just going to apply partitioning to this. We give you all the tools to do this online. You don't have to kick the users out. You can go in there, you can redefine this table, you can copy all the indexes over, you can automate the process of taking a non-partition table and turning it into a partition table. But again, when you make that cut over, one of three things is going to happen. It might be really good for you. Your data warehouse and partition elimination is kicking in, and it's actually making queries run faster. It might do nothing at all. In a transactional system, with partitioning, you're actually hoping that partitioning doesn't make your application slower. It can help with ease of administration, but it might not make your transactional applications run any faster. So having it not change performance at all, that would be a positive thing. The third result could be that it is the beginning of a really bad time for you as you try to back that change out and go back to where you were 5 minutes ago. Online index creates. You've got this query, it's running pretty slow. In your test environment, you created this index, and man, it just goes really fast. It goes from 50,000 IOs down to 3, and you're pretty happy with that. So you implement that index in production, and sure enough, it fixes that query. But unfortunately, it breaks these other two. Because when you add an index, one of three things is going to happen, and you don't know until you try it out. Quiesce. We gave the DBAs in version 9 the ability to pause the database for a minute. I want to make a structural change. I want to do some DDL. I can quiesce the database, which lets existing transactions finish, prevents new ones from starting. When the quiesce command returns, activate my change, and then I can unquiesce the database. And those transactions that wanted to begin start going. Again, one of three things will be the outcome of that at the end. Rolling upgrades. We give you the ability to go from 10.1 to 10.2 without having to shut down and kick your users out for 6 hours. We give you the ability to go from 10.2 to 11.1 in the same fashion. We give you the ability to apply patches in a rolling fashion as well. So you have continuity of operations. However, when you go from 10.2 to 11.1, unless you've thoroughly tested things out, checked them out, one of three things. Probably, if you haven't tested, I can actually say one of one thing. For a major version upgrade, there's going to be something that needs to be looked at attentively. We can completely reconfigure the disk layout of our database online. We can move things around. We can stripe things differently. We can change the entire disk layout online. Again, one of three things. You can either make things better, or you can make things incredibly worse by doing an online reconfiguration. We can take your database these days, and in many cases, back it up on one platform and restore it to another. You don't have to dump and reload. You can just move these databases around. Sounds great until you try it and figure out that, on that operating system, things work a little bit differently than they did over here. And the way we're using the database, this doesn't work out to be a good thing. So we've given you the ability change virtually everything without shutting down. But it's a little bit risky because you don't know exactly what's going to happen. 11G is looking to address a lot of that. So what do we need? We need the ability to set up and have realistic test environments. I don't mean a test environment whereby you get the oldest piece of hardware and a small subset of disks and you try your application on it. That does a good functionality test, but it doesn't test your load, it doesn't test the scale. Capture and replay the workload, trying to emulate what production's doing, trying to mimic what's going to happen in a production environment with 1,000 users doing 100 transactions per second. That's a really hard thing to do these days. Detect and tune performance changes. The good news is 11G has 700 and some odd $V tables with thousands of rows of information in it. Version 6 had like 7 $V tables with a couple dozen rows. So version 11, over 700 $V tables, tens of thousands of rows. The bad news is 11G has over 700 $V tables with tens of thousands of rows. It happens almost every day. Somebody asks a question and I say, well, you could look over here for it. And somebody will come along and say, why didn't you tell them to look at this $V table? It's much easier. And I go, because I didn't even know it was there. Right? Because the list just keeps growing and growing and growing. So we've got all the information we need to figure out what's happening in our systems. We need tools to digest that for us, to turn that data into information. And we'll take a look at that. Provision, upgrade, or clone. Introduce these major release changes without disrupting operations. Package incidents for support. Probably there's at least one person in this room who's opened a TAR. Right? And you know exactly how it goes. It's the same first 3 pages every single time. You know, yes, I have a problem. No, my system's not down. Yes, this is important to me. Okay, can you give us your alert log? Here it is. Ooh, the alert log says you have a trace file. Could you give us the trace file? Yes, here it is. Ooh, you don't know much about your system. Can you run this RDA? Yes, here it is. And now, after you've gone through this sort of little service request dance, you're ready to start working on the problem. We're going to take a look at what 11G is doing and try and automate a lot of this. Total recall, the ability to undo, to put something back the way it was 5 minutes ago, as if it had never, ever happened. And then lastly, I'm going to close up with a little bit of a peek into the future, what's coming in the next releases of the database as far as change management goes. So let's start first with setting up test environments. A test environment today should be a really good copy of the production environment. If a row is in file 5, block 42 in production, I'd like it to be in file 5, block 42 in my test environment, because the number of IOs my queries perform, the query plans that are generated are really dependent on the statistics and where the data resides on the disk. If I copy my production database to test, I can't really do a full-scale performance test on it because it's not going to be exactly the same as production. So we're looking at taking our standby databases, which we've had for many, many releases, going all the way back to 8i, when we first introduced a physical standby database, which is a bit-for-bit, byte-for-byte copy of production. And we're looking at using those for testing instances now. Now, we've taken the standby databases and added a lot of stuff to them over the year. 8i, physical standby, 9i, added a logical standby database. That would allow us to have a standby database that was open continuously, the logical standby, because we're using SQL to copy information from database to database instead of redo information. So people saw this logical standby database and said, this is good, we can start using it for reporting and such. So now we have these 2 different kinds of databases, a physical copy, physical standby database, and a logical one. But the logical standby database didn't support all of the Oracle data types, didn't support all of the database features. So things like the XML type, for example, I couldn't use in logical standby, but I could in physical. Fine-grained access control, I couldn't use that in the logical standby database. It didn't function. So there were certain feature functions that didn't translate. but it was a step up because we could use it for reporting. Now we flash forward to version 11. They've done a couple of things with the standby databases. First, with the logic of standby database, they've removed many of the restrictions. I can use things like the XML type with cloud storage. I have fine-grained access control, fine-grained auditing, transparent data encryption. All of those things are now supported against the logic of standby, so many more people can use it. The real story, though, was the physical standby database. In the past, the physical standby database was typically just in what's known as managed recovery mode. It's applying redo. It's being caught up to the production system. But while it's in that mode, it couldn't be doing anything else. You couldn't use it for reporting. You couldn't really utilize it. It was just sort of sitting over there. And people looked at that and said, it's nice to have it, but it's not providing me any benefit. Starting in 11G, we can do two things with the physical standby that we couldn't in the past. The first one is we can open it for reporting even while it's in managed recovery mode. So now, while it's applying redo, we can query it. As the commit records are hit in the redo stream, that data becomes instantly available so that we have access to it. If production fails, we have the physical standby database. It isn't hours and hours out of sync with production. It's caught up. We can fail over to it immediately. The other thing we can do with it is use it as a testing instance. And this, I think, is the best way to get a test instance. It's a physical bit-for-bit, byte-for-byte copy of production. You know you have all of the data, and you know that the data is laid out exactly the same as it was in production. If I run a query in this test environment and it does 50,000 IOs, I'm pretty sure it's going to do the 50,000 IOs in production because the data is organized identically. The statistics are the same. With this standby instance, you can come in on, say, a Saturday morning, open it up at 9 a.m., take that script that the developers gave you, and the developers promise you the script will run. We've tested it. It will run on their test database, and it runs flawlessly. But their test database is not your production instance. So you run this script in your standby instance. And this script does things like drop columns, add tables, create indexes. That index, man, it needs a lot of temp space, and we didn't have that much configured in our production instance. The script actually would run halfway through and then fail if we would have run it to production. Now we know we need to double the size of temp. Great. We restart the test, and this time we get all the way through. We know what we need to change in order to make this work to be successful in our production environment. We know what's going to happen now when we run the script. We know the outcome of it, and it will be successful. When I'm done with the test, I shut down that standby instance, and using our flashback technology, we put it back the way it was at the beginning of the test and put it back in managed recovery mode. At no time was production not protected. The redo stream continues to be sent from production to the standby site even while we're doing the test. So I still have my failover site, my disaster recovery site, but I've got a testing instance that beats every other testing instance because it's a full copy of reality. Now that I have this testing instance and I want to set up maybe other tests for functionality and whatnot, human beings are going to be querying up the information. I have some other challenges I need to deal with. If I take my employee database and I copy it to a test instance, I might not want people to be able to see names, employee numbers, social security numbers, salary information, other confidential bits and bytes. So we now do have the ability to actually point to a production database, understand the metadata associated with it, the relationships between the table, and extract some subset of this information and mask sensitive information as well. We've got libraries to scramble up names and social security numbers and credit card numbers and all of the kinds of sensitive information you encounter for HIPAA or Sarbanes-Oxley requirements that we can't allow the testers or developers to see. But we need to preserve many attributes of the data. We need to preserve the skew of the information. We need to preserve primary keys and foreign key relationships. If I do a two-table join in production and I get 50 rows, I need to get 50 rows from that two-table join in test as well. So as we're masking the information, it's happening in an intelligent fashion, if you will, so that when it's copied over, the same relationships are still preserved, but the names of the production copy test instance. So now that we have these test instances, we need a way to drive transactions against them in some cases. We use the standby database as an example to perform an application upgrade. After we perform the application upgrade, after we change something in the schema, we added an index, we might want to test that to see what effect it's going to have on everything. This is what I call the killer feature of 11G Release 1. If we were in an elevator together going up 10 floors and you asked me for the one feature of 11G that would be a reason to consider it, real application testing is what I would point to. With real application testing, what we do is we have a process that gets in between your client, say your application servers, and the database. And this process that gets in between here records the conversation. It captures the SQL, captures the PL SQL, captures the bind variable inputs to this, captures ordering information, the system change number, the system commit number, the Oracle internal clock. And it records that part of the conversation, and then it watches the response. It sees what came back out of the database. And it records this information as well. So you go to your production system, 3 o'clock on a busy day, and you start recording. And you record for half an hour. And you're recording 1,000 concurrent users doing 100 transactions per second. You can now take that workload to another system, your standby site, your physical standby database. It's the perfect place to drop this information. We can now make a change on our physical standby database site. So for example, the change I'm making here is I'm going from a single instance of Oracle with 8 CPUs to 2 4-CPU machines in a cluster. We're deciding to go with real application clusters. And when we make this change in production, we'd like to know exactly what's going to happen. Because when we go from single instance to multiple instance, some internal Oracle algorithms change. The way the buffer cache is managed is different. Query plans could even change. Things will be different. And when things become different, one of 3 things happens. We'd like to know which one of the 3 it's going to be prior to inflicting that on our end users. Because end users are like elephants, right? They never, ever forget. 10 years from now, they'll say, you're the people who did this to me. No, we're not going to make any more changes. So we fire up the standby instance under real application clusters, and we replay that workload. And it's going to emulate 1,000 concurrent users doing 100 transactions per second. Hopefully, right? That's what we're hoping that we're going to be able to do. And we could even turn up the volume a little bit if we wanted. We could speed it up. We could make our end users faster. Instead of you waiting 30 seconds between screens, we're going to have you wait 0 seconds between screens. You're going to go as fast as possible. So you can sort of test your system's destruction to see how much faster you could actually go. Can I do 150 transactions per second? Can I do 200 transactions per second? Figure out where I'm going to fail so you know when you need to add capacity to this. But just out of the box, just a single DBA in 3 hours could test what's going to happen when I make this change. Try doing this today without an automated tool like this. Try setting up 1,000 concurrent user tests to drive 100 transactions per second. Even if you go out and buy tools to do this, like Roadrunner or something like that, that takes a team of DBAs to set up the test environment. It takes a team of developers to program it. And it takes a team of functional users to tell the programmers how to successfully emulate, fake out reality here. What we're doing is capturing what actually happened and then replaying it back against that database at that same point in time. We have all of the inputs. We know what we're expecting is the output. The capture process, I should point out, the stuff on this side of the screen, these red arrows, works against now 9.9 Release 2, 9.208, as well as 10G Release 2. So I can capture against an older release of the database and then replay against 11G Release 1. So the replay only works against 11G and above, but it can answer the question, what will happen when I upgrade? What will happen when I patch? What will happen if I change operating systems? What will happen if I gather statistics? Think about that. Why do we gather statistics? To get query plans to change. And why do we get so mad sometimes when query plans change? Because they change in one of 3 ways, once again. We could actually gather our statistics in our standby instance, run our production workload, and then capture the differences between the SQL statements. We'll take a look at the tool that does that for us. And if well, actually identify SQL statements that are running slower. We can then fix them. Maybe I needed a SQL profile. Maybe I needed dynamic sampling. Maybe I needed to gather additional statistics. 11G lets me gather statistics on sets of columns and expressions and things like that. So I have more statistics I can gather. But I fix it over there where nobody's using it for real, and then I just move those statistics into production. So I've offloaded some work to the standby, and I made the gathering of statistics become a very safe thing. In the past, it was sort of a risky proposition. You gather statistics, hold your breath, cross your fingers, and hope everything was okay. And if you were experienced enough, you would know to have kept the old statistics, and you could put them back in place immediately if something went disastrously wrong. Now you can do the statistics, for example, very safely with the knowledge of exactly what's going to happen. So we run all these tests, and we see that we're doing 75 transactions per second after the change instead of 100 transactions per second. We know something's different, and the answer as to what is different is in one of those 700 $V tables somewhere. We've got to go find it. We need tools to do this. We need something to go in with pre-canned queries to go and extract this information. And so one of the tools out there is the SQL Performance Analyzer. The number one cause of performance regression in any sort of change environment is the fact that SQL plans change. And we need to be able to detect when a SQL plan changes, and we need to be able to detect and report whether the change was for the good or didn't affect it at all or affected it in a negative fashion. And that's exactly what this tool does. So, for example, it will come out and tell us most of our queries are running much, much faster after the change. Some of them are completely unchanged. They didn't change the plans at all. What we're interested in, though, is this small bar, the ones that have regressed. These are running slower. Their plans have changed, and they're not performing in the same way that they were in the production environment. We know what they were doing in production because we had access to all that information as we were doing the capture process. We now know that it's changed. We can drill down on those, create a SQL tuning set, and the database will come back and offer up things like, oh, I'll create a SQL profile. I'll analyze your query. I'll look at your where clause, and I'll get better estimated cardinalities, and we'll come up with a better plan. Or we really recommend that you create this index. If you create this index, we estimate that it will do 90% less IOs than it is currently doing. But the database will come back and not only identify the poorly performing SQL, but then offer to try and help fix that poorly performing SQL so that we can make those changes in the test environment before rolling it out into production. Provision, upgrade, or clone. I need to do things like patch my databases, apply critical patch updates, go from major version to major version. Going from major version to major version typically involves at least a 2-hour downtime, if not longer. Because, we can install the software while the database is still up and running. We could use a different Oracle Home or whatnot. But then we have to go through the process of migrating our database. And depending on how much code you have inside of your database, that could be a multi-hour process in order to get that all go through. We can do this now in an online fashion, starting with 10.1 of the database. It requires the use of a standby database. We're going to need a copy of the database in order to do this in an online fashion. But the process is, I've got a standby set up, production going over to the standby site. The standby site might be a physical standby site, might be a logical standby site. In order for this rolling upgrade to work, what we're going to do is, if this is a physical standby database, we're going to start by converting it into a logical standby database, because we need to update the data dictionary and other things like that. We need to apply SQL to it. So we convert the physical into a logical standby database temporarily. We then do the upgrade. We're on version X. The standby becomes version X+1. We then synchronize the two. The standby database can now work in a heterogeneous version environment. The operating systems will be identical, but the versions can be different now in a logical standby database. So we synchronize those two down in step 3, and we switch our users over to the standby site as well, meaning we're going to migrate them from A to B so that everybody is now running on version X+1. And if you're running a standby database, doing the switchover is something easy for you. And you know that because you do it at least 3 or 4 times a year, right? Everybody who has a standby database, you test out the ability to run on the other machine periodically. If you're not doing that, just turn off your standby database, right? Because it probably won't work. There will be something which you physically figured, there will be some procedure, process that you're not aware of how to perform. So the switchover thing is something that you do periodically anyway. Well, we're going to do it in order to facilitate the upgrade. So now everybody's running on the standby site, and the production site is actually in the standby instance. The arrows flip, and the redo starts going in the opposite direction. We can now upgrade our production database to Xmas 1. Those 2 guys synchronize, and then we can switch our users back, and everything's back the way it was. Instead of having hours of downtime, we have a couple of minutes of pauses at the beginning and the end of the upgrade as we're migrating the users from production to standby and then back. If all you wanted to do was upgrade and you're not utilizing a standby database, you can just do the first 2 steps. You would implement a standby database temporarily. We need a copy of this. Then we could upgrade that copy and switch our users over to it. There's nothing saying that we ever have to switch our users back. So you can actually use this in a migration environment, even if you go from hardware platform to hardware platform in a continuous up sort of environment, or to go from major release to major release without having to shut down. Not only major releases, but patches and other changes being done in an online fashion. Packaged incidents for support. We've all been here with the guitar dance. You start that process, and it's always the same. The first 6 hours are identical. It's like Groundhog Day with Bill Murray every morning, 6 a.m., the same song plays over and over again. Starting in 11G, we've changed the way all of the diagnostic information is recorded in the database. We've centralized it into sort of a repository, still in the file system, not in a database per se. It's organized differently. It's also written in different formats. There's not just TRC files, there's TRM files, there's additional information being generated from the database. And some of this information is actually tagged to make the information readable to a program. So we have our alert logs in XML. We have some trace information in XML tagged documents so that we can make better sense of it. In 11G Release 1, we have the capability when something bad happens, you get an OR 600, for example, internal error, to bundle up all of the relevant information associated with that particular error event and move that up to Metalink immediately and have the service request started so the ball is rolling. That's the first step. The next step that's coming into the future is once this information is uploaded to Metalink, they want to start ripping it apart as soon as it gets there. Start running the queries to diagnose what the problem is. If you give me a trace file, giving a support analyst a trace file, they can typically read the beginning of the trace files and pick out bits and pieces of information, query against the bug database, and find a resolution for many problems. It's very rare for someone to hit a bug for the first time. Most of the times when we hit an issue, somebody else has already hit it and resolved it. So the answer is out there, we just have to find it. So the next generation of this software will actually start that query itself. Going even further out into the future, the end goal with this particular utility, this particular capability, is say it's version 13 of Oracle. The DBA is out to lunch, their phone goes off, they open up their email, and it's an email from support saying, you didn't know it, but while you were at lunch, there was a problem with the database. We've already uploaded the information, we diagnosed what's wrong, and we have a list of patches for you to come back and apply when you get back in. So you're not even opening the TARs anymore if you don't want to out in the future. The database is phoning home, if you will, and sending this up. But the first step right now is to automate the creation of the TAR process, and that's available with 11G Release 1. Another thing that they've added that I fully appreciate is a data recovery advisor. I'm curious, how many DBAs in the room? And keep your hands up. Okay. How many of you DBAs with your hands up? Keep on, keep on. How many of you DBAs with your hands up have done a recovery in the last 2 months? a lot less. And so people are like, I'm not really sure. Tell me, when you did that recovery, did you do it blindfolded with your hands tied behind your back because you consider it so easy? Right? You just knew exactly what to do, right? You just walked in there, you looked, and you said, oh, yep, we can fix this. And you typed everything, and you hit enter, and you didn't get that cold feeling where you sweat a little bit. I would have to sit down and start pulling out documentation and saying, this is what we need to do. If you think about it, every recovery scenario probably has multiple opportunities, multiple different ways to do things. And I'm always surprised at people's creativity when it comes to recovery. Let's say you've got a message on your pager, and it says, the database has been shut down by Piedmont because Checkpoint reported a failed write to a control file. The database is down. How do you recover? I know at least 3 ways. Method 1, get the init.org parameter file, comment out that control file name, type startup, time to repair, 20 to 30 seconds. Method 2, figure out which control file has a failed write. You know that one's bad. Get another control file, copy over that one, type startup, time to repair, 30 to 40 seconds. Method 3, start the full restore of the last backup. You laugh, I've seen people do step 3. And once you start that operation, that's like typing commit semicolon enter. Once you've started, you're committed down that path. So DBA 1 starts to restore, DBA 2 is on the phone with support, and DBA 2 says, whoa, stop. Too late. Time to repair there. Maybe forever. Maybe you accidentally overwrote your online redo logs with backed up redo information because you were panicked and you just lost a whole bunch of committed transactions. Now you might not be able to recover the entire database up to the last committed transaction. But the time to repair, a lot more than 30 to 40 seconds, right? It's going to take a long time. If you think about it, when you're in that recovery situation, you're the DBA sitting at the desk, database fails, all of a sudden there's 3 people standing right behind you. And the first one says, what happened? And the second one says, can you fix it? And the third one wants to know, when is it going to be up? Right? And all you want them to do is go away. They're making you nervous, right? So the data recovery advisor is hooked into RMAN, and it's there to answer those 3 questions. What happened? Well, we know what the median failures are. We can tell that this data file went offline because of block corruption, or this data file has block corruption, it's still online. So RMAN can diagnose what happened and report that back to us. Can you fix it? Well, RMAN knows everything that we have. It has the recovery catalog, and RMAN knows the approaches that can be taken. If I have a bad block in a data file, there's at least 2 ways to fix that. Method number 1, block level recovery. If that's a 6 gigabyte file, maybe I don't want to restore a 6 gigabyte file and apply redo to 6 gigabytes of information. I can take the 1 AK block from my backup and restore that. And that's actually an online operation. The data file doesn't even become unavailable. Only queries that are unfortunate enough to hit that block would even know that there's a failure right now. But I can do a block level recovery, or I can take that table space offline, store the entire data file, and then do a complete recovery on it. So RMAN will answer the guy who's standing behind me, and it will even come back and attempt to answer the other person who's asking how long will it take, because it's coming up with estimations on how long each one of these approaches will take to clear the fault, to resolve the problem. And it generates the commands for us. Like I said before, I'm never surprised at people's creativity. I shudder sometimes when I come in the morning and I pull up Ask Tom, and I read the reviews in sort of a FIFO queue, first in, first out. So I might see somebody post something at 1 o'clock in the morning, my time. Help me, my database is down, I'm getting this error. And then 15 minutes later, we typed in these commands and it still failed. And then 15 minutes later, we typed in these commands and now we can't even get it past this point. And 15 minutes later, and then we did this. And I just look at those list of commands, very creative. I have no idea what you're trying to do or why you did it, but now you're really in a bad situation. I never try to help anybody with recovery online because you need to extract a lot of information from them. You need to understand everything that's going on, and that's what this is all about. So I'm hoping that people start using this instead of trying to guess what went wrong, and trying to guess what would be the right sequence of, what's the right incarnation of commands to make my database come back to life. Total recall, the ability to unsay something, to undo something. This slide should actually go much further back in time itself. It starts at 9.9. But this capability, this flashback capability, was actually introduced into the database in version 4 way back in 1983, 84. This capability was a thing we call multi-versioning and read consistency. In version 4, if you opened up a query at 9 o'clock in the morning and you waited 3 hours to select from it, so you came back at noon, when you fetch information from it at noon, one of two things would happen. Either you would get the data that was in the database at 9 a.m., because the query would always only see the database as of 9 a.m., or you would get an OR 1555 snapshot too old. Right? But hopefully, you get the information. And this was done through read consistency, fixing a query at a point in time. Starting at 9.9, we exposed this to the developers, to the end users, to the DBAs. I could log into a database at noon and say, select star from these tables as of 9 a.m. Flash back to that point in time. We're using the same exact technique we were using in version 4. So nothing changed. We just exposed that. But why was this useful? How would I use this? You're the developer. You typed in the right command, delete from configuration table, semicolon, commit, semicolon. As your pinky's leaving the enter key, you realize you typed in the right command in the wrong database. Right? You've got 15 windows up. When you do that, I've done this, where you do a cut and paste, and there's a lot more in your cut buffer than you thought there was. You see those commands go by, and you're just hoping nothing is bad. You need to undo this. Well, I just deleted all the configuration information in the production database. This is confirmed by the fact that my phone is now ringing. What do? 8i? What would you do as a developer? There's only one thing you could do. You go to the DBA and you ask them politely if they can help you recover some of this data. And after they're done laughing at you, they have to come up with a way to restore this. And that's going to impact their life, right? They're going to spend time doing this. So it's a pain for them. So one of the things might be, your application's not that important. Here's an export from last week. You get out what you can, and you update the last week's changes if you need to. If it's a critical application, they might have to go through the process of, okay, we're going to do a table space point time recovery over here. We're going to recover it until just a minute before you did your mistake. We then have to export that information because we only need that table, and then we're going to import that over here. But now they have to go through this process, and this might take, some amount of time. With a flashback query, as the phone is ringing, the developer can just go insert into table, select start from table as of 5 minutes ago, 500 rows inserted, commit, pick up the phone. Application's failing. Can you hit reload? It's working? Great. And no one is the wiser. But that's what this flashback technology is about. Undoing whoops operations. So in Tenji, they give us things like flashback table. I can undrop a database table. We've all been there, where you run that script and you see the drop table go by and you're like, oh, no, and you hit Control-C, but it's too late. You can now undrop that table. You can put tables back the way they were. Instead of having to know the SQL you have to perform to restore the table, you can just say, put these tables, these 5 tables, back to the way they were 10 minutes ago, consistently as a single transaction. We introduced a flashback database. Remember that one example I gave with the developers had run the test script, but they ran it in their test database. When you go run it in production, it fails halfway through. But it's done some things that can't be rolled back, like create tables, create indexes, and drop columns. You can use a flashback database to to sort of set a save point in the database. Before I run your potentially deadly script, I'm going to mark a save point. I'm going to run your script, and if it fails, I'm going to flash back to that save point. So it's sort of like a system restore point inside of Windows. This is the only time I'll ever compare Oracle to Windows. But it's the same sort of concept. Mark this place, save enough accounting information, enough images of data in order to get back to this point in time rapidly and as fast as possible. It's sort of a replacement for full restore, cancel-based recovery. In fact, it's exactly a replacement for that. And in older releases, if I ran that script and it crashed halfway through, I would go to my last backup, restore it, do a point-in-time recovery, and stop just a minute before we started this application upgrade. So it's a faster way to recover from that. In 11G, we've added one new capability to the flashback stuff. When the 9i flashback query came out, one of the first questions people started asking was, ooh, so I can query the table as of 3 hours ago, 5 hours ago, and 5 days ago. How about 5 months ago or 5 years ago? Because then I can get rid of my auditing tables. This is my audit trail all of a sudden. So no, the flashback query won't go more than 5 days theoretically in the past. I say theoretically because flashback query, as it is in 9i and 10G, is based on undo information. And it is highly unlikely that any DBA would keep 5 days of undo online. So in order to flash back 5 days ago, they'd have to actually configure undo to be that large. And if we were to support 5 years ago, they'd have to keep 5 years of undo online. And nobody's going to do that. It's just too much information. The other problem is the flashback query is non-scalable, meaning the further back in time you flash back, the more hours you ask us to go back, the longer it takes, because it's a linear process. In order to flash back an hour ago, what we do is we read a block from the table, and we look at that block and say, have you been modified in the last hour? If so, go to undo that change, reconstruct the block before that last change. Now, this new block, have you been modified in the last hour? Yes, go to undo and undo this change. If you had 10,000 updates to that block in the last hour, there will be 10,000 rollbacks that take place. If you had 10,000 in the last hour, you probably had 100,000 in the last 2 days. It's going to take much longer to flash back 2 days ago than it does an hour ago. And now think about 10 years ago. Get that first block. Have you been modified in the last 10 years? Are you kidding? Yeah. And then you have to walk through that. 10 years later, you get block 1, and now you're moved on to block 2, and you have to go through the same process. So in 11G, they've introduced a new segment, if you will, a thing we call a flashback data archive. So the DBA would come into the database and say, these 3 tables, they're really important. We need to maintain a history of them, either for HIPAA requirements or Sarbanes-Oxley. The auditors are going to come in and ensure that we can query this table far back into the past. It's our HR information. And to solve lawsuits and things like that, we need the HR data that we've retained for 20 years for each employee. Well, we're going to point to a table and say, I need to retain the information in this table, this audit trail, for 3 years. Or I need to retain the information in this table for 5 years. So table by table, the DBA is going to set up a retention policy and place tables into these flash data archives. Now, it doesn't actually move the production information. My order table stays there. The only thing that's going into these archives are the changes. And the way this happens is applications do their inserts, updates, and deletes against the order table. That generates undo. If I update a row, we have to generate undo. That's always happened. When we commit, a background process, FDTA, the Flashback Data Archives, comes through and is looking through the undo information for undo generated against the tables the DBA has in the archives. When it finds undo for the orders table, it takes that undo, gets the database block that it should be applied to, applies it, gets the before image of that record that we just modified, and puts that into the Flashback Data Archive. Now, in order to query 5 years in the past, all we have to do is get the current information and the row that was in place 5 years ago. When we put the table in the Flash Data Archive,
We have all of your columns, plus we've added a couple of extra columns of counting information so that we can rapidly find the row that was in place 5 years ago. So rather than undoing 5 years worth of changes, we just get two images, the current one and the one that was there 5 years ago. If there wasn't one there 5 years ago, we'd use the current image. If there was one there 5 years ago, we'd use that image. So you get to query the table as of 5 years ago in a scalable fashion. It takes no longer to flashback query 5 years than it does 10 years or 15 years, because it's the same amount of work. We just have two things to consider: the record that was there 10 years ago, if any was there, and the current version of the record as it exists now. So it gives us a very long-term flashback query capability in a scalable fashion, and it's done at the table level. The flashback query based on undo, that's database-wide. It's all of undo. This is just taking the undo for tables of interest and copying it over. So it's not consuming terabytes and petabytes of storage. It's just consuming as much storage as it needs to keep all of those row versions. The other thing it does is this last point here in red, it prevents change. This is a talk about implementing change, right? This is a feature that prevents change, meaning I can't drop this table anymore. I can't truncate it. I can't drop a column. I can't do anything that would cause a non-auditable event to occur, even if I connect /assistDBA. I go in as the Oracle super user. SysDBA can't drop the table, can't truncate the table. The database prevents all of those operations from taking place. There's no opportunity for having a whoops type operation here. The auditors can come in and look and say, okay, I'm pretty convinced this table hasn't been tampered with. I have to actually take the table out of the flash data archive in order to perform those operations. I have to disable this feature entirely on that table, and that would set off alarm bells all over the place. A question?
Does this require online undo?
Does this require online undo? The flashback data archive process, shortly after you commit, is mining this information. So as soon as you commit, somebody's coming in and reading it, finding the relevant information against the orders table, undoing that operation, and putting the row over there. We no longer need the undo information at all. So as soon as you commit, flashback data archive is coming in and reading that information, and then that information can be overwritten. So this changes none of your undo retention policies or anything else like that. We'll need to make sure the undo retention policy in the undo space is set sufficiently large so that we can mine this information before we try to overwrite it. Otherwise, you'll be waiting for the flashback data archive process and introducing some pauses into your system. But in general, you're going to turn this on, and it's not going to change the way anything works. You can turn this on a third-party application, happens in the background. You can turn this on as a developed application, happens in the background. And it doesn't affect their performance at all, because they still have to generate undo. They're not doing anything extra to make this happen. It's just that background process is going to be reading the undo, copying out the interesting bits of it into the flash data archive, and then that undo is free to be reused as in the old days. So it doesn't require that undo to stay forever. Will still allow you to partition the table. Yes, and in fact, you can even partition the flash data archive stuff. In the flashback data archive, there is just a table. There's an actual table there. It's a table you can't do inserts, updates, or deletes against, but you can actually select, you can look at it, it's got a structure. You can manage that table like anything else. You can even add additional indexes to it. So yes, the data in the flash data archive can be, and the original base table can be as well. So it doesn't really impose restrictions on what you can do with your data. Short of, it can't drop a column, for example. If you did want to drop a column, how would you do that? If you were using this, you would use a view. You would rename the table. You'd create a view as the table name and select out just the columns you want. We can't let you drop that column because you told us this information needs to be queryable as of that point in time in the past. 5 years ago, that column existed. 5 years from now, that column still needs to exist in the base table. So there's ways to accomplish everything. Views, hiding, data type type changes, column names, the fact that the column was dropped or whatever. It just changes perhaps the way that DBA is going to implement those changes.
So essentially, I set up my
I'm sorry, you're going to have to shout.
I want to start 5 years of data today, right? And then 5 years from now, I'm looking to drop in another year's worth of data. So how does it work in terms of flashback data? Does the database drop the data that it doesn't require, or do we have to go in and purge as the years go by?
Okay, so the question is about purging and maintaining this information. When you set up a flash data archive, you specify a retention policy on it. Things I put in here are going to be retained for 3 years. The DBAs can go in and manually purge. We don't really need 3 years anymore. We only need 2. So let's purge all but the last 2 years worth of information. So there are manual commands, but by default, it's done automatically. When we get 3 years of archive information, we start deleting the old records and reusing that space in a big circular queue. So if you set up a retention policy of 6 months, 6 months from now, your flash data archive will probably hit a steady state size. It will grow for 6 months because we're adding to it, but at the end of 6 months, we'll start deleting old information and inserting new information for you. So you can either manage it manually or let it manage it itself.
So it works like a retention. Previously, it's a retention based on the whole database. Now it's retention based on undo.
Right. So this is another comment about retention. And previously, with flashback query, this retention was specified at the entire database level. It would say undo retention 2 days, and all undo for 2 days to be kept. Now I can put a table in the flash data archive and say this table 2 months, and it's only that table that will be preserved over there. So it's getting darker and darker. So with the flashback data archives, the only thing in the flash data archives is the previous images of rows. It's not undo information, it's actually structured information, and only for the tables of interest, and only for the duration of time that you would require. So it is much less space hungry, if you will. If you have a large database and you had 2 days of undo retention, that segment's going to be rather large, that undo table space. On the other hand, now you can set up undo retention to be 3 hours. So undo is real small, but you could put some tables into a 2-day flash data archive. It doesn't have to be years in the past. It can just be longer in the past, and that gives you the ability to do things like flashback query against it, guaranteed for the last 2 days. And that could be part of your recovery benefits as well. Because, these tables are really, really important. And sometimes we need to reset them because we run simulations. We run what-if analysis against it. Sometimes we need to put them back the way they were. Well, I can guarantee you that these 5 tables in this flash data archive have sufficient information to be put back the way they were. And then I want to close up briefly with a glance into the future. We give you all these online things. We give you now the tools to implement that safely. So you can go from version X to version X plus 1 and know in advance what's going to happen. We can remove downtime because we have the rolling window upgrades and things like that. But what we can't do is remove downtime when you want to take your applications or your third-party application from version A to version B. If you run Oracle apps, for example, going from version X to version X plus 1 might be, depending on your implementation, a 24, 36, 48-hour event. Why? Because they compile a ton of code, they do a lot of changes. It takes a long time to upgrade the application, and that's an offline operation. Coming soon, meaning next release, and this is, by the way, a beta sort of feature, so if it doesn't actually happen in the next release, I'm off the hook. It's not been announced. This is just our future direction. Coming soon is the ability to have the same code in the database, 2 versions of a procedure exist in a schema simultaneously. I've got procedure P, and it runs for version 1. For version 2, I still have procedure P, but maybe the inputs have changed or the logic has changed. In the past, if I compiled procedure P in for version 2, version 1 would just disappear, be gone. And everything that called procedure P would go invalid and probably be broken because we changed the inputs and whatnot. We'd have to compile all of this code. And that's why our upgrades are offline. So with this capability, I can actually create procedure P in a single schema while the old procedure P is still there. We've extended the namespace so that you can have different versions of the code existing simultaneously. So the DBA can actually install version 2. We're going to drop this procedure, we're going to create this new procedure, we're going to modify this existing procedure, we're going to change these views, we have these new triggers, we can stage all of our code for version 2 in the database. We can do things like create indexes that are invisible. This is a feature in 11G Release 1, actually. An invisible index won't be used by any of the existing queries out there. Because when we add an index, it might make some queries actually run slower. And we haven't tested this new index against our old queries. We don't want to destabilize version 1, but we want everything for version 2 to be out there. So we can stage all of our application changes, and then when we're ready to go to version 2, we just flip a switch, and we're running version 2 code. So the goal going forward is to remove that last barrier to continuous availability, which is upgrading our own applications. And this is something the Oracle Applications Group actually drove all of the requirements for, because they need to take this 24-hour process and turn it into a 2-second process. From the DBA perspective, it's still going to be a 24-hour process, right? But from the end user perspective, it's going to be an instantaneous, oh, we were running version 1, now we're running version 2. I think one more question.
Speaking of version 2, when is 11G version 2 coming out?
When is 11G Release 2 coming out? It has not yet been announced, but as I understand it, there's a large conference that takes place on the West Coast later this year where typically large product announcements are done. Wink, wink, right? So I would look at it from a company perspective as a 2010 event in your life, because the announcement would almost surely be coming at that point in time, which is near the end of the year. Right? And we got Thanksgiving and Christmas, and nothing happens anyway, so then we're
This year is going to be really to release 12 version 1 for the applications probably next year for 11G release 2. That's what 12.1 for the applications this year and 11G release 2 next year.
It's a comment on application releases and stuff like that. And
That's also a big release, yeah.
And he says, that's also a big release. I'll have to trust you because that's applications, and in Oracle that's a totally different career path. Right? So I don't really follow the application release cycle, so I can't comment on that even a little bit. But I thank you very much for your time and your attention, and I hope you enjoy the rest of the day. I know the speakers that are coming in the afternoon talking about doing safe upgrades, best practices. It's good stuff. It is well worth your time sticking around and hearing about it. Even if you're planning on going from 9 to 10, any of the things that we talked about are going to be extremely